Hello, hi everybody. We are just going to start off with the chapter called percentages. Percentages is one of the most vital chapters. It's one of the most vital and the most important chapters for any competitive exam that you're going to take. Trust me, if you know percentages well, then I believe you will be able to solve 50 to 40% of the entire examination of the entire paper, which has quantitative aptitude in it. So, in terms of quantitative aptitude, percentages forms the bedrock. It forms the bedrock of all the other chapters, and the primary reason for it is because percentages deals with numbers, and most of the numbers are originating from 2 or 3 chapters. The chapters are percentages, then the chapter is um, this ratio and proportions. So these two chapters are very, very important when it comes to simple algebraic level mathematics. So they have a very key role. They are the core subjects, they are the core chapters which you need to study in order to do well in the other chapters. Okay, so trust me, this is the most important chapter that you'll ever face. And when I talk about percentages, I'll try to break it down in the easiest possible format so that any person, any guy, any person, any layman can understand what I'm talking about. Okay, so per space cent. Okay, can you see what I've done? I've just like split per and cent. Cent means 100. All right, in $1 there are 100 cents, so cent means 100 and per means every. So we talk about percentages in the sense of something there being in every 100. Okay, something being present or something being absent out of every 100 things. So that is what we call percentages. Now I have a very small example to help you understand. Okay, I'll draw stick figures of 5 students. Okay, these are just sticks and you have to consider 5 of them. Okay, I'm just making a head and I'm considering all of them, like some of them to be males or some of them to be females. Okay, these are stick figures of 5 students. Now in this particular stick figure, what we can say, the total number of students is equal to 5. Now when I talk about proportion, proportion means that I have to find out what stands valid, for a certain case and what doesn't stand valid for another certain case. When I talk about 1 out of 5, that means for every 5 people I pick up, there should be one who follows certain thing or not. I'll make it easy with the help of an example. When I talk about wearing black socks, okay, black socks is my case, black socks. Okay, so out of these 5 students, if one of them is wearing a pair of black socks, then 1 out of 5 would stand for 20%. How did I arrive at this 20%? From a fraction. If I am supposed to reach a point where percentage is available, I will have to multiply it by 100. I will have to multiply it by 100. So in the same sense, I multiplied 1 by 5 by 100. 5 ones are 5, 5 20s are 100. So here with 20, I can fix or I can juxtapose the sign of percentage. To remove the sign of percentage from somewhere, I can very easily say I'm moving from this corner to this corner. Okay, I'll remove this line. I'll just put a hash over here so that you know this is hash 1 and hash 2. Okay, so the 20% that we have over here, if I wish to change it to a fraction format. From percentage to fraction, I will have to divide it by 100. Okay, this changes to 20 upon 100. 20 ones are 25s are, and this comes down to 1 by 5. I hope you're understanding what I mean. 1 by 5. This is the same thing which happened over here. So in the percentages chapter, I'll be just quickly revising whatever I've said in this entire slide, and then I'll move to the other slide. The point here is that percentages is a very vital subject. It is the bedrock of everything that we have to do in the upcoming exams, in the upcoming papers. And not only percentages and ratio proportion, all the other chapters like mensuration, algebra, trigonometry, and other places have very simple application of percentages. So we will have to keep in mind the very rock solid foundation of percentages. The second thing is that per and cent when split comes out to be every 100, and I drew a small set of stick figures to help you understand when I talk about 1 out of 5. Let's assume if I talk about 2 out of 5. So 2 out of 5 would give me 40%. Okay, 2 out of 5 would give me 40%, and 3 out of 5 would give me 50%. No, 3 out of 5 would give me 60%, 4 out of 5 would give me 80%, and 5 out of 5 would give me 100%. Okay, so I've made it pretty clear of how percentages work. Moving on to the next option, the fractions which we have, the fractions which we have are pretty simple to understand. Okay, I'll help you understand it. 1 in itself is equal to 100%. Okay, I'll just help you derive and help you understand where this 1 is coming from and what is going on in the mind of the examiner, as well as how it all started. Well, in the beginning of time, mathematics was definitely there. Mathematics, and like when I talk about beginning of time, I don't mean the Big Bang theory or the black hole theory or some sort of that time. When maths was invented and things came into picture, there was a time when analog was being converted into digital. Okay, the analog was being converted into digital, and this was being done to transfer signals from one place to the other. Like you might have heard a little bit about Morse codes or some other sort of codes, or Boolean algebra. If someone of you might, if some of you might have read a little about Boolean algebra in computer science, you would know that the Boolean algebra is based on binary numbers. Okay, binary numbers. It is based on binary numbers, and it only has one switch. Okay, it might get a little complicated for everybody, but trust me when I say, if you understand the simple concept of 0 and 1, the entire chapter has so many beautiful tricks, has so many beautiful ways of solving, and so many, like, you can solve it without a pen as well. The entire mathematics which I am going to teach is going to be a little verbal. Okay, you might be able to understand, you might be able to pick up and do and solve questions without even using the pen. Okay, so Boolean algebra, it is based on 0 and 1. Okay, so this is the binary system which it works on. So when the signals were being converted from analog to digital, there was only one kind of a signal: on and off. This is a signal of one kind only. Either it stays on or either it stays off. So every time the signal is on, it is 1, and every time the signal is off, it is 0. When I talk about 0, here it means 0%, and when I talk about 1, it means full throttle, that is 100%. Okay, so this is how analog was turned into digital, by simply a button, like press it on, like this is on and this is off. So if the key is here, it's on, key is here, it is off. So I hope you understand where I'm bringing the concept of 1 being equal to 100%. 100% means full throttle, full energy, completion, something being present, and everything that is positive. That is 1. And everything that is negative. Negative would be a very wrong connotation of it, but everything which is absent, everything which is not there, that means 0. Like if somebody talks about darkness and somebody talks about light. When somebody talks about darkness, they might call it negative thing. And when somebody talks about life, with light, about light, they mean positive. So a very beautiful definition of darkness is it is the absence of light. Okay. And also a very beautiful definition of courage. Courage, it is not the absence of fear, but is the conquest of fear. It is the conquest of fear. I'm not a motivation speaker, so I don't have more elaborate definitions of courage. So courage is the conquest of fear. This is motivation 101. Okay, now moving on, I've talked about fraction over here. 1 is equal to 100%. So we are in the position of taking it forward. Fraction, okay, fraction. Have you ever heard that he rushed, he rushed from this place in a fraction of a second? In the fraction of the second, the lightning occurred. Lightning means the lightning. There's a difference between lighting and lightning. Lighting means my surrounding which has light. Lightning means the thunder, the cloud, or the visible light which shows up when there's a cloudy weather. Okay, so it's basically the transfer of ions between the earth and the clouds. Because just to tell you that I am a science student as well, I know what lightning means, so that you don't consider me to be some random person teaching mathematics only. So when I talk about fraction, fraction of a second, okay, when I talk about fraction, it means I am splitting one into its own parts, into a few parts. When I split 1 into 1, when I split 1 into 1, I tend to create just one portion of 1. But when I split 1 by 2, one whole into two parts, then I create two equal parts of 1, which come down to 0.5 each. 0.5 each. Moving on, this 0.5 can be denoted as 100 divided by 2, 1 being complete and 2 being the part of 100, which comes down to 50%, 50%, or 1 by 2. This is the percentage form and this is the fraction form. This is the percentage form, this is the fraction form. I'm going down to the depth of it. Okay, so I really want you to have your night vision on. I really want you to have your torches on and dig very deep with me in percentages, because somebody who fears maths will also be able to crack this very, very well. So 1 by 2 is equal to 50%. When I split it to 1 by 3, I talk about 100 being split into 3 equal parts. And those 3 equal parts, my friend, are 33.33, 1, 33.33 second, and 33.33 third. Third, okay, first, second, and third. I might have used the wrong fingers, first, second, and third. Okay, so we have 3 parts: the first part, the second part, and the third part. Because they are equal parts, that is why there is no differentiation. And fraction means division of something by or the division of a bigger number by a smaller quantity, or maybe an equal quantity, just to split it, just to split it into equal numbers, be it be it as many as possible. Okay, 33.33%. So every time you see 1 by 3, you are supposed to recall that 1 by 3 is equal to 33.33%. Okay, I will be highlighting, I'll be encircling this entire slide, I'll be encircling the important areas in this entire slide, so that every time you come back you don't have to read it entirely. But I'm pretty sure by the words like Morse code, binary, boolean, on and off, 50%, fraction, light, courage, conquest, you would be able to figure out what I was talking about. Okay, moving on, there's a very important solution which I'm coming up to. Some people tend to misunderstand 33%, and some people tend to misunderstand and really very, it's a very naive mistake which comes up, that 33% and 33.33%, both of them are interchangeable. The reality is somebody like a layman or somebody might do this mistake, but you being a student of any competitive exam, international, Indian, or whatever competitive exam you're looking forward to, 33% and 33.33% are not the same. I repeat, 33% and 33.33% are not the same. Considering 300 rupees. Okay, when I talk about 33.33% of 300 rupees, it means 300 divided by 3. Okay, because I'm using this formula. This formula means 1 by 3. So it gives me 100 rupees. Am I happy with the 100 rupees? Answer is yes. But when I talk about 33% of 300 rupees, it comes down to 99 rupees. So every time on a 300 rupee product, there is a 33.33% discount. So you are in a better position. You are in a happier place, because you will have to pay 100 rupees less. But if there is a 33% discount, then you're not in a very happy place, because you will only get 99 rupees off, not 100. So 1 rupee has its value. So always remember, 33% and 33.33% are not interchangeable quantities. You would find multiple questions out there which have 33% written, and you would mark the wrong answer, because in the options, I'm very sure about it, that in the options there would be 99 as well as 100 as two options, and you might go for 99 just because you saw the question wrong, or you might go for 100 as well. Okay, so 1 by 3, I've made you understand what it is about. Coming down to 1 by 4, in the next slide you'll see multiple forms of these fractions, and you'll just go through them, you'll be able to understand what I was talking about. 1 by 4, again 100 divided by 4. Taking it forward, 100 divided by 4 is equal to 25%. Okay, so 1 by 4 is equal to 25%. Pretty easy. Out of, it means out of every 4, 1 is being chosen. Okay, I'll just write it down for you. Out of every 4, 1 is being chosen. Okay, 1 is being chosen out of every 4. Similarly, 1 by 5 would make it 20%. 1 by 6 would be 16, 2 by 3%. If you can just look into my eyes, I'll talk about all of them and try to memorize it with me before moving on to the next slide where original all the values are there. If you'd listen to me once, maybe my voice would hit you somewhere on the inside and say, okay, sir is talking about the right thing, or maybe big brother is talking about the right thing. 1 upon 1 is 100%. 1 upon 2 is 50%. 1 upon 3 is 33.33%, not 33. 1 upon 4 is 25%. 1 upon 5 is 20%. 1 upon 6 is 16 2 by 3% in fractions. 16.66% in decimal format. Okay. 1 by 7 is 14 2 by 7. 14 2 by 7 percentage in mixed fraction, and 14.28 in decimal format. 1 by 8 is equal to 12.5%. 1 by 9 is 11 1 by 9%. 1 by 10 is 10%. 1 by 11 is 9 1 by 11%. Look how this beautiful couple works. When I talked about 1 by 9, when I talked about 1 by 9, just look at me, okay? No need to look at the screen. Just look at me. I'm on your left or maybe right hand side. 1 by 9 is 9 being 9 staying in the denominator, and 11 as a couple of 9 coming on its left hand side, left upper side. Similarly, 1 by 11, we have 11 coming in the denominator and 9 being its couple coming on the left hand side with the percentage sign. 1 by 12 being 8.33% or 8 1 by 3%. 1 by 13, 1 by 13 being 7.69%. This is something which you will have to remember. You will have to remember this. No matter what happens, you will have to remember this. Okay, it is 7.69% or 7 9 by 13. 7 9 by 13%. 1 by 14, okay, it must be somewhere around 6%, but we will definitely talk about it later. Till 1 by 13 things are pretty important, and like me, like I know about it, about them pretty well, you should also know about them pretty well. Now I'm moving on to the real theory part, which is already written in the slides. You just have to go through them, and if you want, I will encircle the points which are very important. Let me first encircle the points which are important in the previous slide as well as this slide, then I'll come down to here. Okay, I've talked about the bedrock, it being percentages, it being a vital part, about these stick figure of students, stick figure of students. Okay, then talking about who's wearing black socks, who is wearing black socks, then fraction being a part of something, part of something, then 20% as a fraction being 1 by 5 and 1 by 5 being a fraction of 20%. Then fractions over here, 1 being 100%, analog to digital conversion. This is the core theory. Okay, this is the core. I am like redoing it so that you know that this is a little important. Somebody might ask you, somebody who's like really wise, like why percentages occurred, where did 1 come from, where did 0 come from. So this should be your answer. A little bit about Morse code, a little bit about Boolean algebra, darkness and courage, courage being the conquest of fear. Okay, I might have missed this part. And light, there being 1 being 100% and 0 being 0%. The first fraction is 50% is equal to 1 by 2. Okay, and 100 by 3 being 33.33%, and 33% and 33.33% not being the same. 1 by 4 being 25%, and but out of every 4, this is not but, this is out of every 4, 1 is being chosen. Okay, 1 is being chosen. So I've pretty much covered the entire standard basics of percentages. In the upcoming slides you would see different concepts now. So percentage is a number or a ratio that can be expressed as a fraction of 100, as a portion of 100. I've already talked about this, as a fraction of 100 or as a portion of 100. Percent being per 100, it is represented by this symbol of a slash with two small zeros around it. Okay, a slash with two small zeros around it. This is a forward slash, right? So forward slash, if I have a percentage and I wish to remove it, I will have to divide by 100. If I don't have a percentage and I wish to bring percentage into the picture, then I will have to multiply by 100. Okay, this some important fractions, we've done it, we've done it, we've done it. 2 by 3 is just a part. of 1 by 3. We've just multiplied 33 by 0.33 by 2, which is 66.66. Moving on, 20% is 1 by 5. Again, 2 by 5 is a portion of 1 by 5, which is twice the portion of 1 by 5, being 40%, this being 60%, this being 80%. All I'm just taking you through them like over and over again so that you never forget it. 1 by 6, I made you recall this in the last slide, okay? 16.66 or 16.67. 5 by 6 is again a derivation of this. It's a derivation of this, okay? I'll just do it for you. 16 2 by 3 multiplied by 5. Okay, so what I can do is I can separately multiply both the things. 5 multiplied by 16 plus 5 multiplied by 2 by 3. I believe many students might not know how I can write 6 2 by 3 plus into two portions, 16 plus 2 by 3. Okay, I'll just show you how. 5 16s are 80 or 16 5s are 80 plus 5 2s are 10, 10 upon 3. 10 upon 3 is further splittable into 3 times 3 and 1 being left behind. This 3 times 3 would come out and would be represented as 80 plus 3 plus 1 by 3, and the answer would be 83 1 by 3 percentage. Okay, okay, did I make myself clear? I really wish if you could tell me back some or the other way, but maybe we would have comments and something coming up very soon. Okay, 16 2 by 3. This is how you can split. There's a relationship of plus in mixed fractions. Always remember this. There is a relationship of plus in mixed fractions. There's one step I might have missed, and that is 83 plus 1 by 3. You can remove the plus sign and juxtapose them together to achieve 83 1 by 3. Okay, I hope we are doing fine, we are doing well till now. 1 by 7 being 14.28% or 14 2 by 7, then these are just derivations. Okay, these are just derivations, and you can remember it if you want to. You should never forget the 1 by 7 and 1 by 6 formats, but you can falter on 2 by 7, but trust me, it is still going to cost you in the exam, because it's difficult to recall that okay, 14 is being multiplied by 2 and 28 4 by 7. Okay, this might be somewhat 2 by 7. It's easy to catch 14 2 by 7. So once you're thorough with the 1 by n or 1 by x or whatever you may call, 1 by 5 6 7 8 9 10 till 15 or maybe till 20, then you can move on to doing 2 by 7 2 by 8 or something. Okay, simply going ahead, 1 by 8 is 12.5. This is interchangeable. This is not clearly interchangeable but somewhat interchangeable by 1 by 12, which is equal to 8.33. Okay, it will be coming in the next slide and I'll talk about it. I talked about a couple. I talked about a couple, 1 by 9 and 1 by 11, how beautifully they are interchangeable and how there is no new number coming up in the equation. Okay, 1 by 10 being 10% is clear. Okay, moving on. 1 by 12, another, like not a very compatible couple as good as 9 and 11, but a decent enough couple. 1 by 12 is equal to 8 1 by 3 and 1 by 8 is equal to 12.5. Okay, so this is one more couple. 1 by 13 being 7.69%. I've already talked about it. Okay, I'm writing it here, 7.69%. You can recall any of the two, whichever you find good. 1 by 14 being 7 1 by 7 and 1 by 15 being 6 2 by 3. Okay, these are also a little important. If you really have the focus, if you really have the courage, you may definitely really want to do it. Okay, focus on the ones which I've already done. They are good enough to get you through. Once you get a habit, once you are doing fine, then you can move on to these ones. There's a small fraction, this is a small question. Change percentage into fraction. I divide it by 100. But when I want to change a fraction into percentage, then I multiply by 100. If I wish to remove the percentage symbol, then I divide by 100. Divide by 100 when I wish to remove the percentage symbol. Okay, it's 20 divided by 100, which is equal to 1 by 5. Change fraction into percentage, like 1 by 4, then I multiply by 100. 1 by 4 into 100 equals 25%. I hope I've made myself very clear. I would request the viewers, I would request the students to come back, look me right in the eye, and talk about all the fractions which we've talked about and converted them into percentages. Repeat after me. 1 upon 1 is 100. 1 upon 2 is 50%. 1 upon 3 is 33.33%, and not just 33%. 1 upon 4 is 25%. 1 upon 5 is 20%. 1 upon 6 is 16 2 by 3%, or 16.66%. 1 by 7 is 14 2 by 7%, or 14.28%. 1 by 8 is 12.5%. 1 by 12 is a little interchangeable with 1 by 8. 1 by 12 is equal to 8.33%. I'm going back. 1 by 8 is equal to 12.5%. 1 by 9 is 11 1 by 9%. 1 by 10 is 10%. 1 by 11 is 9 1 by 11. 1 by 12 is 8 1 by 3%. 1 by 13 is 7.69%. 1 by 14 is 7 1 by 7%. It is 7 1 by 7%. 1 by 15 is 6 2 by 3%. 1 by 16 is 6 1 by 4%, or 6.25%. 1 by 15 is 6 2 by 3%. 1 by 17, 18, 19 not required right now. 1 by 5 is 20%. 1 by 25 is 4%. You remember how 1 by 4 is equal to 25% and how 1 by 25 is 4%. So these are interchangeable. You let the percentage sign remain there, you pull it down and put it to the denominator. You can exchange the numbers really well. Okay, I'll just give you a few examples of exchanging these numbers so that you're able to understand what I'm talking about. Remember, if somebody used to say, give me 10% of 70, and it could be easily interchangeable with give me 7% of 100, or it could be give me 70% of 10, or it could give me 700% of 1. All these statements have the same answer, because every time there is a percentage sign, you can interchange it with the quantity which is available. Always remember, you can interchange it with only one quantity, not with all of them. Not with all of them. So I'll show you how. When I talk about 10%, let me make it 20%. Okay. When I talk about 20%, then I talk about 1 by 5. Okay. When I talk about 20%, I talk about 1 by 5. When I talk about 5, then I can write 1 by 20. Did you get it? Did you get it of what I am talking about? 5% is equal to 1 by 20 times of something. Okay, let the percentage sign stay there and you can move the digits left and right. But always remember, you have to pick up the whole digit and put it there. You can't say, okay, this is going to be, this is a wrong statement here. When you tell me that 20% is equal to 1 by 5 and you talk about 50%, hey, this is also fine. This is also fine. 50% being 1 by 2. This is just maybe one example which works out well, but trust me, you have to move the entire number. You have to move the entire number. I'm rubbing off this part because my assumption came out to be a little wrong, but I hope you understand what I'm talking about over here. Okay, removing this. I'm removing this part because I thought that this assumption might stand true, but you always have to take the entire number, put it there, take the entire number on the left hand side and put it down. So I think we've completed the theory part of numbers, theory part of everything, and we are ready to move on to a few questions. Okay, there is already a little bit of ink here, so please ignore it. The question says 72% of students are interested in mathematics. 72% of 25 students are interested in mathematics. How many students are not interested in mathematics? Okay, so I am trying to draw a small field over here. Okay, this is a classroom. These are the benches. Okay, the benches being divided into maybe something of this sort, and there are 1 2 3 4 5 6 7 8 9. Okay, and 10 11 12. So some people, some of them, as already stated in the question, some of them are whatever portion I'm shading, I am assuming that it is interested out of this entire class. Okay, and whatever portion I'm shading by the other ink, let's say this purple ink, they are not interested in mathematics, not interested, and the other type is interested. Interested in mathematics. Okay, so what we have to find out is how many students are not interested in mathematics. The question here says how many, so it is talking about number, it is not talking about percentage. So out of 25 students, I'm considering, firstly considering 100% to be the main number. Okay, I'm considering 100% to be the total number of students in the classroom. We are very optimistic, that is why we'll consider the case to be favorable. We will consider the case to be favorable at all times. So the favorable case is the entire classroom is interested in mathematics. So 100%, 25. When I talk about only 72% students being in favor of mathematics, then what is the number of students who are not interested in mathematics? Simple mathematics. Okay, this was a pun. 100 minus 72 comes down to 28%. Okay, 100 minus 72. This is 28%. Now, this 28%, I will have to multiply it by 25 because I wish to find out that portion of the class which is not interested in mathematics. Using the biggest numbers, 25 ones are 25 and 25 fours are 100. The bigger number you use, the quicker your calculations would be. I could have gone for 5 fives are 25 and 5 2 and 25 20s are 100. So I will not use small numbers, I will use big numbers. 4 ones are 4 and 4 sevens are 28. So are 7 students are not interested. interested in mathematics. Okay, thank you. Moving on to the next question. If Chameli had 600 rupees left, if Chameli had 600 rupees left after spending 75% of her money, how much did she have? How much did she have in the beginning? Me being an optimistic teacher and you being an optimistic student should always think that Chameli had 100% of the money with her. Okay, that Chameli had 100% of the money with her. She, according to the question, has already spent 75% of the money. Okay, has already spent 75% of the money. So what is the money that she is left with? 100% minus 75% equals 25%. So she is left with 25% money. According to the question, the value of 25 is 600 rupees. Okay, so I am putting it down in the most easy form of unitary concept. If the value of 25% is equal to 600 rupees, and we, being the most optimistic people on the planet, have assumed that Chameli had 100% money in her pocket, so what would the value of 100% be? So the unitary concept says that from 25% you move to 1%. 1% of 25 would give 25 ones are 25 fours are, so 6 fours are 24 rupees. And then if 1% is equal to 24, we just need to attach two zeros to the end of 24 to find out our final answer. But this method which I have done on the right, this is the standard. This is the standard unitary concept. What I want you people, the ones who are watching me, what I want you people to learn is a fast track unitary concept. Fast track unitary concept. What does the fast track unitary concept talk about? 25% is equal to 600. 25% times 4 gives me 100%. Logical enough? Logical enough, yeah. If I've multiplied 4 on the left hand side, this is the left hand side. If I've multiplied 4 on the left hand side, I will have to multiply 4 on the right hand side as well. Okay, I'll just change the color so that you can understand what I'm talking about. If I've multiplied 4 on the left hand side, I can multiply 4 on the right hand side. I will have to multiply 4 on the right hand side as well. 4 6 are 24, 4 600s are 2400, like is 2400. So 2400 rupees is our answer. Always think, learn of solving things with the fast track unitary concept. Even if you still follow standard unitary concept, believe you me, I have no problem. But just to save maybe 2 or 3 seconds out of your entire calculation, I would recommend go for the fast track unitary concept. Okay, an item is marked at 840 rupees. It is sold for 714. What is the discount and what is the discount percentage? Before talking about the discount and the discount percentage, I really want you to deep, dig very deep into the concept of profit and loss, because this concept is definitely going to come to you some or the other time. In this particular concept, you have to consider yourself to be a shopkeeper. Okay, shopkeeper buys from Wholesaler. Wholesaler. Who is a wholesaler? A wholesaler is somebody who accommodates a very large amount of the goods, and he is somebody who's acquiring a large amount of the goods, maybe directly from the company or maybe from a bigger wholesaler. So he has a good margin. He has a good margin. When I talk about margin, means every time he's selling the product, he is having a good profit percentage. So this is how the shopkeeper works. He buys from a wholesaler, and wholesaler already has a good margin. So you, being the shopkeeper in this case, hypothetically speaking, buy from a shopkeeper, buy from a wholesaler, and whatever you buy it at cost price. Whatever the shopkeeper buys it, he buys it at a cost price. Then I am moving one step forward. There is something which the shopkeeper always keeps in mind. If he wants to become a very top-notch shopkeeper, he must attract people with a lot of discount. But if he would attract people on discount by showing them, okay, my entire shop is on sale, flat 70% off, flat 50% off, so there is a good possibility that he might make no margins or he might even go in loss. This can be a case. But because he is a smart shopkeeper and he has learned mathematics the right way, he's learned street style mathematics, so he knows he would keep the profit the same, and he would increase the final selling price, the selling price which is displayed. He would increase the displayed selling price so that even after offering a very lucrative discount, a very attractive discount to the men and the ladies out there who are buying products, he still gets a profit. You understand? Even after selling things at a discount, he is quietly making profit. So be a shopkeeper. I'll show you how. In the cost price, he puts in his profit and also adds a few droplets of discount. A few droplets of discount. That makes up the marked price. That makes up the marked price. And look how it turns out to be. He gives a small discount or maybe even a large discount just to attract the public. He gives a discount and he reaches a point where he is ready to sell the good. The good means the goods. The goods. Nobody's selling good out there. Everybody's selling goods out there. This is a very deep statement. You must learn from it. So, selling price. Selling price. I hope you can see. Cost price is CP, marked price is MP, and selling price is SP. Okay. Now, the difference between the selling price and the mark price is the discount offered. And the difference between the cost price and the selling price, if it is positive, if it is positive, he has gained. If it is negative, he has loss, or he has like acquired a loss, or he has lost money. Okay. If he has gained, positive profit, negative loss. I've rewritten whatever I wanted to talk about. See how well we did here. Now we know the entire game of cost price, mark price, selling price, profit, discount, everything. We know everything. Okay, I'll tell you what we need to do with the question now. The question says the item is marked at 840 rupees. Tell me the discount first. you need to know the discount. This is the mark price. The mark price and the selling price need to be subtracted from each other. That is what would bring the discount. And the discount here is 126 rupees. The discount is in rupees. It is also asking for the discount in terms of percentage. As I've told you here, the discount is already focusing on the mark price. It is not going towards selling price. Okay, so the discount is always focused on the mark price. So I wish to take out the discount percentage. I would just write the entire formula here. Discount percentage is equal to discount in rupees. I'm just putting R symbol here so that you know what I'm talking about. Discount in rupees divided by the mark price, again in rupees, multiplied by 100. So this is a formula. If you really want to keep it with you, please go ahead. So the discount percentage would be 126 divided by the mark price, which is 840. Do not commit the mistake of having 714 in the denominator, because that is the selling price, not the mark price. I am cancelling it. 7 or maybe 12. Okay, 12 sevens are 84. This is not going by 12. Okay, so this is how mistakes are made. I'll just cancel out the 0 with the 0. I'll make it with 7. 7 12s are 84. 7 1s are 7. 7 18s are 7 8s are okay. 7 8s are 56. Again 6 2s are 12 and 6 3s are 18. This is 30. 2 5s are 10. 5 3s are 15. So 15% is our discount percentage. 15% is our discount percentage. This is the discount, this is the discount percentage, and we have reached our final question. For one last time, whenever I keep my pen down, it means I'm seriously talking business. Okay, for one last time, I'm going to repeat how you have to deal with when you're a shopkeeper. Okay, how deliberately you have to stay when you're a shopkeeper. When you're a shopkeeper, you have to buy from a wholesaler. All the money that you give to the wholesaler to buy the product from him and keep in your shop becomes your cost price. Got it? Now, every time you are going to write down the prices on your commodities, on your goods, you have to always keep in mind that you will have the profit as well as discount in it. If you wish to be a very clear shopkeeper and you don't allow any sort of bargains, you can just keep the profit there and put a selling price tag on it. Okay, so cost price should have profit and discount included, and then it should be marked. If you wish to attract more customers, you wish to give them lucrative offers, you have to have profit and discount added on the mark price. And to attract more customers and being a lucrative shopkeeper, you must give some or the other discount. When you give the discount, you have to calculate the discount on the mark price. Once you give the discount and deduct that money, you have to deduct that money from the mark price. From the mark price, when you remove the discount and you sell the product, whatever you accept from the customer, whatever money you accept from the customer becomes the selling price. After deducting the cost price away from the selling price, if you still have any money left, that would be your profit. Okay, concept clear, question clear, moving on. The list price of a frock. A frock, if people who don't know what a frock is kind of a one-piece dress for very young, very young girls. Okay, very young girls, they wear the one-piece dresses and they are called frocks. It has a lot of frills. Okay, so The list price of a frock is 220. A discount of 20% is announced. A discount of 20% is discount on sales. What is the amount of discount on it and the sale price? Okay, okay. Again, I am sitting at the same concept. List price. The word list price can be interchangeably, this is the sign of interchangeably, used with mark price. Okay, so let me sit on it in the same way. The cost price, the selling price, the mark price. The mark price is 220. The selling price needs to be found, the sale price and the discount needs to be found. So when I move from mark price to selling price, there is a discount associated. The discount associated according to the question is 20%. If I wish to find out the selling price, I will have to deduct selling price is equal to marked price minus discount. Mark price minus discount, and both the quantities should be in the same units, that is rupees, the same currency. Okay, so the discount percentage is 20%, and the discount percentage, whenever it needs to be converted to discount, we have discount upon MP into 100. I'm using the formulas for those students who don't understand where things are coming from. And trust me, there is no harm in being that student who doesn't understand where the quantities are coming from. And even if you work with formulas, you will still clear the examination. Remember that. Okay. So D percent is 20% divided by discount, which we are looking for, multiplied by, like, divided by 220. Whatever I'm doing is all written over here. Okay, so I will remove this discount, this 0 with 0, and to remove this percentage sign I would divide by 100 again. So 20 into 22 divided by 10. Okay, so this comes out to be 44 rupees. So 44 rupees is the amount of discount, and the final sale price, the final sale price would be, final sale price the final sale price would be 220 minus 44 rupees. Okay, minus 44 rupees, that would be 176 rupees. This is one of the final answers, this is the second final answer. I hope you're able to understand where we are. Okay, now moving on. The cost price of a pair of roller skates, the cost price of a pair of roller skates is was 450 rupees. The sales tax was charged 5%. Find the bill amount. Okay, now I will help you understand a little bit of the concept of sales tax. Okay, sales tax is the tax which you collect from the customer on the event of a sale or at the event of a sale. Okay, so you are selling something, and at the event, what is the event? The event is sale. At the event of a sale, you collect sales tax, and the sales tax goes to the government. This is pretty much about the laws which are prevailing in India. Outside, it might be a little different. It might be totally different outside, but the sales tax goes to the government. So when you're preparing a bill, when you're preparing a bill, at that time, what you have to do is the cost, or I would cancel it. the selling price plus the sales tax. This has to be paid by the customer. Paid by the customer. Okay, remember this. The selling price as well as the sales tax has to be paid by the customer. Coming down to the point ahead, there is the cost is 450 rupees and the sales tax would be applied on this 450 rupees. 5%. Removing the 5%, I would have to, removing the percentage sign from this equation, I would have to have upon 100 in this particular equation. 0 is cancelled out with 0. 5 ones are 5. 5 twos are 10. 2 by 45 is equal to 22.5%. No, 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 no. There's no percentage. This is 22.5 rupees. 22.5 rupees. So the extra money which is being charged, the extra money which is being charged is the sales tax, and the sales tax is 22.5 rupees. This amount of 22.5 rupees would be added in the total bill, will be added in the total bill, and the bill is rupees 450. 450 plus 22.5, which makes it 472.5 rupees. Okay, did you get it? Did you understand what I'm talking about? So this is pretty much it. We'll be covering more questions in the upcoming video.